Determine whether mean value theorem can be applied and do it. Let's say x plus 3 times the natural log of x plus 3. So f of x is x plus 3 times the natural log of x plus 3. And we're doing it from -2 to -1. All right, so first thing for mean value theorem, we just have to make sure that that's continuous and differentiable from -2 to -1. And it is. So we put -2 in here, we get the natural log of 1, which is 1, or 0. And we get the natural log of 2, it's continuous everywhere in between. So then the mean value theorem tells us somewhere the first derivative equals the average rate of change. Right, so first derivative, we'd have to do the product order. Derivative of x plus 3 is 1, then multiply by the natural log of x plus 3. Add to that the derivative of the natural log of x plus 3, which is 1 over x plus 3 times x plus 3. And then that's got to equal f of -1 minus f of -2.
You said the order doesn't matter as much as the order.
The same both times, yeah. It's like you're finding the slope of a line. It doesn't matter which point you start and stop as long as you just go for the same. Like these are the y's. This is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So up here we get the natural, or the left, we get the natural log of x plus 3 plus 1. That's going to equal, if we put -1 in here, we'll get 2 times the natural log of 2. Minus, put -1 in there, we get -1 plus, oh, put -2 in there, we get 1 times the natural log of 1, which is 0. And that's over 1. So then you just said natural log of x plus 3 equals 2 natural log of 2.
Yeah.
You're missing that. And then from this, then we can say this natural log really means log base e. So we could say x plus 3 equals e raised to this. And then take the 3 to the other side, it becomes negative. They might even make this e to the natural log of 4 minus 1. And then we can make this -3 plus e to the natural log of 4.
Do you have to keep parentheses there to the form?
Well, you could, but I know it's an x right there. So that this, when you add, when you multiply, you add. So e to the natural log of 4 times e to the -1 is the same thing as e to the natural log of 4 minus 1. So I get -3 plus e to the natural log of 4 is 4. And it's times e to the -1. And that was times. So we get -3 plus 4 over e. Which they might make that -3e plus 4 over e. Put that over 1, multiply top by that. It's just like that.
Putting x equals 1, I did it like 2 or 3 times, and it's like, what's wrong?
You know, it's fun to do on these two, or what's helps with the learning maybe is check out this graph. So we didn't have this luxury when I was rich. We didn't have this cool calculation. So x plus 3 times the natural log of x plus 3. I'm going to change the window to go from -2 to -1. And then zoom fit. So this is saying that that value for x that we figured out, the slope of a tangent line equals the average rate of change. Actually, I don't know what I'm doing now.
I'm gonna say, how
So
was
we're
that?
not, yeah, we're not doing about CFR. Well, let's do this. Let's go on here. Let's do, let's calculate the value of this function at -3 plus 4 over e. It's right there. That means if I drew a tangent line right here, there's that point right there. I drew a line tangent to the curve right there at that point. That should be parallel to, and it's sort of messed up where this one here, a secant line through these 2 points. All right, I'll probably just show something that's a little bit more, but but there's other things we can do to check too. We can check, see they're saying here, actually I guess we could have done this. We could have gotten to calculate the derivative. We figure out the derivative at -3 plus 4 over e. The derivative is 1 point. That's 1 point. .38. I wonder if that's the same thing as 2. It's right here. 2 natural log of 2 minus 1. Oh, not minus 1, just 2 natural log of 2. Because that's what we got when we found the average rate of change right there. Look at that. Because these are about what we were trying to figure out. Where does the average rate of change? Okay, well there we go. That was the whole thing of the mean value theorem, was to try to figure out where does the average rate of change equal the instantaneous rate of change.